Hey, what's up, y'all? Thanks so much for joining me for another processing tutorial, this one again on images. Today we are going to look at how to make this neat little kaleidoscope effect using PGraphics, and I think we're also going to delve into P3D, which is the renderer that you can use in processing to operate in 3 dimensions instead of just 2, right? So let's think about how a kaleidoscope works in real life, right? And that'll kind of help us figure out what we need to do in our code to get this effect, right? So a kaleidoscope in real life, it's like a mirrors inside of a tube, right? With like a picture or something at the back of the tube that you can rotate around, and that changes what each of the reflections look like in the mirror. And that's how you get this kaleidoscopic effect, right? And so those are kind of the 2 things that we need to figure out how to do, is like, how do we rotate this picture 360 degrees? And then how do we mirror that image, in this case 4 times across the screen? Okay, cool. So let's exit this and get to work. All right, so we'll make a new sketch. We'll say void setup and void draw, right? I'll need to save my sketch so that I can put an image into the data folder. We'll call this kaleidoscope, all right? And then let's add a file. And this is a picture of ice under a microscope. It's got some nice kind of differences in the color, and like the angular shapes make just for kind of like a nice kaleidoscope picture. Y'all, of course, can put any photograph that you would like into this PImage that we're about to create to get your own sort of customized version of this sketch. So let's say PImage ice, and let's make our size 640 by 480, and then we'll say ice equals load image. And we will say, what is this called? Microscopic ice.png. Okay, and let's resize it. Ice.resize width height, right? And then let's draw it to the screen. So we'll say background is red and image ice at 0, 0. Okay, great. So we've got our sketch window here. We've got the picture of microscopic ice here, or ice under a microscope rather, displayed here on the screen, and it's been resized so that none of the background is peeking through. Let's start to figure out how we're going to rotate this. So the image is being drawn from this top left corner up here, which means that we can't just use a rotate function all by itself. Check out what happens if we do that. We can say rotate angle, and let's make ourselves a variable, and let's set that variable equal to a mapping of mouse x, which we know goes between 0 and 640. We're going to do a full 360 rotation, so we'll say 2 pi. Right, so now when I move my mouse, it's rotating, but it's going around from the top left corner, and you can see as it comes all the way back around close to 360 degrees, or 2 pi over here, right? It comes back onto the screen. This is not what we want, obviously, right? Now you can see this red background peeking through, and that is not what we want for our sketch here. So what we need to do is we need to actually first translate to the center of the screen, apply the rotation, and then translate back to the origin, right? So to do that, let's go ahead and say translate width divided by 2, height divided by 2, right? And then we'll want to translate back negative width divided by 2, negative height divided by 2. Okay, and excellent. Now I am rotating this picture from the center with these 2 translations that they end up canceling each other out, right? You can see that I'm going width and height divided by 2, and then I'm going opposite. I'm going back, right, away from the origin by height and width divided by 2, right? So those are canceling each other out. But by using that and putting the rotation in between, right, that allows me to rotate this picture, which its origin, right, is up at 0, 0 up there, because that's where I'm drawing it, around the center. Okay, great. Next, what we want to do is figure out how to get rid of this red space, right? So what we're going to do is we're actually going to scale the image up. So we can say something like scale, I think at this resolution 1.5 times might be okay. At the resolution we were at for the example, it's 1280 by 720. I think you need at least a scale of 2. Okay, so now we're running into another issue, right? This picture is no longer centered because of this scale function here, right? So let's take a look at what we need to do with the math to recenter it, right? So if this is our original display window size here, right, and we scale it up, we need to actually move the image back a little bit and move it up a little bit, right, so that the origin here, when it was, you know, the same size as the display window was here, that origin needs to move left and up, right, to still center this image. So if we look here, we can take the width, right, of the scaled image, right, so scaled width, right, and we can subtract that from the display width, right, and that will give us all of this area on either side of it, right? So that will give me this plus this. And if I divide that amount in 2, then I will get just this amount, right? And that's the perfect amount to translate backwards in the on the x-axis to center this photo. And the same can be done here, right? This is my scaled height, and then this is my display height, right? And I just take this and I subtract my display height from it. I take the scaled height, which is this length here, and I subtract the display height, and then I'm left over with this and this, right? So these two areas above and below the display window, and I can just divide that in 2, and that's the perfect amount to go up, right? Negative, translate negative y some amount, right? And that amount is the scaled amount minus the display width amount, or height amount, right? So basically what I'm going to have to put into processing is like scaled width minus the display width, right, divided by 2, and then this would be inside of like a translate function, right? I would say scaled height minus the height of the display window divided by 2. And that should figure out for me where I need to translate on the x and y axis to center this image, no matter what I scale it to, right? So let's go ahead and put that in. Let's head back to the code window. And we do actually need to put that translation before all of this rotation code, right? So maybe I'll add a couple of comments. We'll say rotate image from center, right? And the reason we have to put it before this, right, is because these translates basically cancel out, and this is just now like doing the rotation. So again, remember way back to the earlier videos when we were going over 2D translations, right? If we rotate, or sorry, if we translate after a rotation, that really messes things up, right? And so we are going to want to translate first, right? So let's center scaled image, right? And so what we need to do is we need to take the scaled width, right? So we can say width, translate, right? Width minus the scaled width, right? Which is like width times 1.5, right? Divided by 2. And I'm probably going to need a few parentheses just to make this math work out correctly, right? So we're going to take the width of our display window. We're going to subtract the scaled width, right? So how big is our picture actually right now with this scale being applied down here, right? And we're going to divide that in 2. And then we're going to do the same thing. So let's say height minus height times our scale amount, right, divided by 2. This needs to go here, actually, for that to work out. Okay, Good. So let's take a look and see if this is working. Okay, so it seems more centered. And now if I rotate, it's kind of working, but not quite. Okay, so let me think about why that's not working. Okay, it's because these translations also need to reflect that. So, yes, okay, because the picture is bigger now than this actual width. Okay, so what I would need to do is I would need to come in here and say width times the amount of scale, height times the amount of scale, right? And then I need to go back that amount, width times the amount of scale, height times the amount of scale. Okay, let's see. Okay, now it is behaving as expected, and we can just adjust this scale amount. You can see it needs to be a little bit bigger so that this red area around the top and the bottom of the image goes away. So you know what? I should have probably done this before, but let's say S for scale and S equals 1.5. So all these places I have 1.5. I'm going to replace with S. This actually doesn't matter anymore. Okay. And 1.5 was too small, so let's do 1.8. See if that is big enough for this resolution. Okay, so that seems to be big enough to cover everything, which is great. Okay, so now we've got this image that stays centered while we rotate it and does not reveal any of the background. Excellent. I think if I wanted to put the control in here, I think I also did this for the example. 0 and height. I guess I should be putting this, shouldn't I? Okay, between 1.8 and how about let's say 2.8. Okay, cool. So now should be able to scale this up, right? And it should still rotate from the center, which it seems to be doing at no matter what scale amount I have. Okay, so this seems to be working well now. Let's move on now to figuring out how we're going to mirror this image 4 times around inside of our display window. Let's go back to our pen and paper for a moment, right? And think about how the rotations that we've been doing in the past are really just in 2 dimensions, right? And so when we're rotating a flat surface, we just rotate it, you know, like this. But if we use 3 dimensions, right? If we start thinking in 3D, and we'll use the P3D renderer in size. I'll show you how that looks in the code in just a second. We now actually have access to 3 axes, right? We can use the x-axis, the y-axis, and the z-axis, right? And so if you look at this is my display window, right? This is the y-axis going up and down. This is the x-axis going left to right. And the z-axis actually comes out of the page, right, and goes toward you. And maybe you can think of this like, you know, there's like a space inside of it, right? So it's going in and out, right? So that's that z-axis, right? So if I rotate that z-axis, right, it's going to behave just like our rotations have been, right? If I rotate this picture around the z-axis, right, it's going to behave just like rotate has been behaving in 2D land, right? But if I rotate, let's say I have this picture right here, and I rotate it around the y-axis, what's going to happen is it's going to flip, right? It's now being rotated around this axis. It's actually going to flip and rotate this way, right? So if it was a 90-degree rotation, the image, you wouldn't actually be able to see it because it'd be sticking straight up, right? But if I rotate this 180 degrees around the y-axis, all of a sudden you've flipped that picture around, right? And now it's mirrored around this y-axis, right? And I can do the same thing. I can take it from here and I can mirror it around the x-axis. Again, like, you know, if I were to just rotate 90 degrees, it'd be sticking straight up and you wouldn't actually be able to see it. But as I continue that rotation all the way to 180 degrees, right, now I'm getting a mirror image here, right? So we started here, we rotated this way, right? And then we rotated it up this way, and then we can rotate it again this way, and then we can rotate it again this way, right? And so you can see by rotating in 3D around the x and the y axes, we're going to be able to draw a mirrored image. So let me draw it out for y'all. So if this is our first time and we go here, right? So we leave this one here, and we've just rotated around the y-axis. Now we've got this mirrored image. If we rotate this around the x-axis and we leave this one here, right, now we've got this mirrored image. And if we do that one final time around this y-axis, then we'll get another mirrored image here. And all of a sudden you can see we've got a little kaleidoscope, right, with a bunch of 4 mirrored images, right? And so all we had to do was just rotate around the x and the y axes while in 3D. So let's go back to processing. And here in setup, to operate in 3D land, all you have to write is P3D. Done. Now, what we're going to want to do is, instead of drawing, you know, this picture 4 times on its own, right, we're going to start using PGraphics now. And doing that is going to allow us to actually have like a border for each of the copies that we're making. If we just were, you know, using the image itself, when you put 2 of them together, right, and now they're, you know, kind of moving around, they're going to stack on top of each other as they rotate and stuff, and we don't want that, right? We just want to be able to see what's in the frame, right, that we're creating. So that's where the P graphic is going to come in. So we have changed our renderer to P3D. Let's start by making a P graphic, PG, PGraphics, PG, right? And what we're going to do is we are going to make our P graphic 1/4 of the width and the height of our sketch window. That way we can put, you know, 4 of them inside of one sketch. So I'm going to say PG equals create graphics, and this needs to be, I think they actually need to have integers, right? And we're going to need these in a minute as well for some of these calculations here. So let's go ahead and make some variables. Let's say int PG width and PG height, and we'll say PG width is equal to width divided by 4, and PG height is equal to height divided by 4, and then we'll say PG width, PG height, and this needs to be the same renderer, right, P3D, so that we can use the rotation in the different x and y axes. Okay, so let's see if we can now kind of recreate all of this stuff onto the P graphic and then draw that to our screen, right? So let's get rid of this and let's just start by, let's do this. Let's say PG dot begin draw, PG dot end draw, right? And we'll say PG dot background 0, just to see what it looks like, right? And then here, let's get rid of all this for just a moment, and we'll say image PG 00. And let's just see what that gets us. Okay, awesome. I messed up the math. We actually want, okay, we're going to fit 4 of them on the screen. They only need to be divided by 2. Okay, right, so this will take up 1/4 of our screen. So now let's start drawing what we were doing before to our P image. Okay, so actually what we want to do is maybe take this and move it after we've calculated the P graphic width and height, so that we can just say, I want this to be, the same size basically, right, as the little P graphic that we've created. And then I can come here and I can say pg.image ice 00, and that should now draw this image to the P graphic, and then we're going to draw the P graphic to the screen. Okay, nice. So here is our picture of microscopic ice. Now we need to rotate it and all of that. So what we can do is we can say pg.translate. So where are we going to go? We need to go from, okay, so here's what we need to do. We actually need to take the P graphic width times the scale amount, right? And divide that by 2. And then we need to take the P graphic height times the scale amount, right? Divide that by 2. Okay, and we need to say pg.rotate angle, right? And actually, this is in 3D, right? So I want to tell it, I'm actually going to rotate around the z-axis, right? Because this is what's actually going to spin everything for me. So I'm going to rotate around the z-axis by the angle amount, right? And then I'm going to say pg.translate, again, all of this, but negative, right? Let's go back to where we started. Okay. We'll need to add that translation beforehand, so we'll say pg.translate. And so we're thinking, again, the width of the P graphic minus that width that's been scaled divided by 2. So I might even just take all of this math here, throw it up here, and just come in here and say P graphic width, that's why I know I'm not going to mess up P graphic height, any of the math that we already figured out. And then, of course, before I display my image, I'm going to say pg.scale, the amount of scale. Okay, I think that's everything. Let's see how we did. Okay, all right, so now, as you can see, we've got one P graphic here that is centering the image, rotating it, and as I move my mouse up and down, I can also scale it. And no matter how big or small it is, it's always staying centered. Excellent. Okay, so now our task is to simply take this P image, right, that we're drawing here, and display it 4 times and rotate it around the display window. So let's do that. Let's actually first go to the center. That way we only have to use one translate. And we can just use rotates after this. Okay, so now my P graphic is down here. And let's go just the same way that we went in the example that I was drawing out for y'all a second ago. So first thing we're going to do is take this P image and we are going to rotate it around the y-axis, right? So let's see what that looks like. I can now say rotate y by pi. And then let's display that image one more time. See what we get. Okay, awesome, right? So you can see we've just taken this image and rotated it around the y-axis one time, and we've got a little kaleidoscope kind of mirror effect going on down here in the bottom half of our screen. Let's do the next rotation. So we're going to take now, so we've rotated once this way. We're going to now rotate up along the x-axis. So I'm going to say rotate x, again, just by 180 degrees or pi, right? I'm going to display that image again. And I'll let y'all see what that looks like. Okay, we filled in 3 out of the 4 bits here. let's do the last one. So now we're up here, right? All we need to do is rotate once more around the y-axis. So I can say rotate y, again, just by 180 degrees or by pi. So I just flip that image one more time. Then I draw the image like so. And I should, here we go, awesome. Okay, so now I have a kaleidoscope that covers the whole screen that I can kind of play with the mouse, and I can zoom in and out by going up and down, and I can spin it in either direction here, right, by moving the mouse left and right. And so, of course, you saw in the intro that the example I had animated, right, and you can do all of that just the same, I'll show you how to just animate the rotation like this. So we can say angle plus equals like 0.001, or how about 0.01, right? So this will just automatically increment the angle every single time. So instead of using my mouse to control it, I should probably initialize it as 0. And we're just going to increment that value every time we run through the draw loop. And it should kind of move automatically. Nice. And now my mouse is just controlling the zoom. I think I also had it set up that to actually have my mouse X be changing like the speed. So I had another variable in here instead of this being a hard-coded value. So you can change the speed of the rotation. You could make it so that the speed variable that you create can be negative as well. So maybe you want to spin the images in the other direction, right? And you could also animate this zoom in and zoom out effect, or you could map this to amplitude, or you could map this to some other piece of music, right? So now you've got some parameters here of this kaleidoscope that you can think about mapping. All right, and so this is our working kaleidoscope. Like I said, my example code had a few more bells and whistles, but this is enough to get y'all started, and you can figure out how you can map these different parameters to elements of your musical performance, or again, if you want it to just be like kind of an interactive piece that people can play around with, you can figure out what kind of control systems you want. But that's everything for the video for today, so I'll see y'all in the next one.